Okay, so in this problem, you're given the radius of each of these solids of rotation is 3. So if that's 3, the height of the cone was twice the radius, so that's going to be 6. What that means is that this portion of your solid is going to be 6 units. If the whole thing has a height of 28, you now know there's 22 left for this remaining portion. Okay, so the question becomes, how do you know what the height is for this cylinder and or this hemisphere? Well, the fact that this radius right here is 3 means that anywhere you draw this radius, so here and here, even though these are different lengths as far as the 2 dimensions that we see, they represent the same length in the 3 dimensions. So what that means is from the center to the edge of this hemisphere, anywhere on the edge is a distance of 3. So that means that this distance from here to here will also be 3 for a total of 9, representing of that 28. So that leaves for this middle portion, the cylinder, 19. Okay? And so what you can do now is find the volume of each of those individual pieces. So the volume of the cone is going to be 1/3 pi r squared h, where the radius is 3, the height was 6. This 3 cancels with this 3, or one of the 3's, leaving 18 pi. Okay, the volume of the cylinder is pi r squared h, okay, where the radius is 3 again, and this time the height is 19. 3 squared is 9. 9 times 19 gives you 171 pi for the total. And then finally, the volume of the hemisphere down here is equal to 1/2 of the corresponding sphere, 4 pi r cubed. Okay, and so these can reduce, giving you 2/3 pi times our radius here of 3. And so this 3 cancels with one of these 3's. 3 squared is 9 times 2 is 18 pi once again. So our total is going to be the sum of all these. If you add them together, and you get 207. And then the decimal equivalent of that is your final solution here, 650.31 approximately. The units were given as centimeters. It's a volume, so it's cubic centimeters.